All right, we're going to work on example number 5, linear program number 5. Now, we may have played this song before on the videos, but by golly, this is the song we need for this problem. Moving to the country, gonna eat a lot of peaches. So we're talking about how to create peaches. All right, so this problem is set up such that we have, I guess, citrus fruit peaches. Yeah, they're practically citrus. We have 3 groves where we have citrus plants. We have Mount Dora, Eustis, and Claremont. All right, we have different amounts of bushels of peaches in each of these locations. And so the question we want to think about is how do we ship those to the processing plants located in Ocala, Orlando, and Leesburg, such that we get charged per bushel mile that we ship. And so we want to minimize the total number of bushel miles the fruit must be shipped. All right, so we're going to set up the linear program by hand. And the way we're going to do that is we're going to think about the groves where we have peach trees. So there is a peach tree. And then we have these factories where they grow and eat a lot of peaches. All right, so that's what we're going to do. All right, so what we want to be able to do is to notice that we have something in Mount Dora. We have another grove in Eustis. We have one in Claremont. Well, we have a packaging plant in Ocala, Orlando, and Leesburg. So we want to be able to define our variables. Well, if we're going from Mount Dora to Ocala, well, we could ship peaches from Mount Dora to Ocala. Let's let that be X1. But we could also ship peaches from Mount Dora the Explorer to Orlando. That's X2. And then we could also ship peaches to Leesburg, which would be X3. So the grove in Mount Dora, we could choose 3 different locations to send our peaches. Well, what about from Eustis? Well, Eustis we can send to Ocala, call that X4, to Orlando, call that X5, or to Leesburg, call it X6. So now we have 6 variables. But wait, we're not done. All right, we're going Claremont to Ocala, that's X7. All right, Claremont to Orlando, that's X8. And Claremont to Leesburg, that's X9. So those are our 9 variables. So what we want is let X1 equal number of bushels from Mount Dora to Ocala. All right, and then we're going to have that for all 9 of these. So we have 9 variables. Well, what we want to be able to do is to minimize the distance between each one. So our objective is to minimize that distance. Well, how would you write out that actual objective function? All right, well, that objective function looks at the distance between each one. So the distance between Mount Dora and Ocala, as we point out, is 21 miles. So this is going to be 21 times the number of bushels we send from Mount Dora to Ocala, which was X1. All right, so let's write this out. The objective is to minimize 21 times X1 plus 50 X2 plus 40 X3 plus 35 X4 plus 30 X5 plus 22 X6 plus 55 X7 plus 20 X8 plus 25 X9. So that there is our objective function. Okay? Well, what constraints do we have now? So let's add our constraints. So our constraint is that we take all the peaches in Mount Dora and ship them away to a plant. So the peaches that are coming from Mount Dora is X1 plus X2 plus X3. This has to equal 275,000. So we ship off all of those peaches. Well, Eustis has 400,000 bushels. So x4 plus x5 plus x6 is equal to 400,000. Okay, and x7 plus x8 plus x9, so all those from Claremont need to be shipped out, and that's 300,000. Okay, so now we've shipped all of our peaches out, so our grove constraint is taken care of. Now we just got to think of our processing constraint, because each facility can only handle so many peaches. Well, if that's the case, the peaches that Ocala receives, which is x1, x4, x7, so x1, x4, x7, so x1 plus x4 plus x7 has to be less than or equal to the capacity, which is 200,000. x2 plus x5 plus x8 has to be less than the capacity in Orlando, which is 600,000. And then the capacity at Leesburg, which is x3 plus x6 plus x9, has to be less than or equal to that capacity there, which is 225,000. And so that there is our linear program for example number 5. And to send us out, let's go ahead and listen to more of the presidents of the United States.